And so here is the second problem. They're asking us to determine the nature of the solutions of the equations. And then they give us a quadratic equation here, and they give us some possibilities of what those solutions will be. They don't actually want us to find the solutions. Now, really where we're at right here is math that I think is not going to be around in 10 or 20 years for sure. There's really no reason to talk about what's known as the discriminant. But at the same time, they're asking us to do this, so let's do it. And let's do a good job on it. I wanted to actually grow your math brain here by just pointing something out that may have slipped past you. What I have here is a quadratic equation, the standard form of a quadratic equation that is descending order. Everything on one side is 0 on the other. I've written the coefficients in red because really what's going on here with the quadratic formula, what it's saying to us is that you could take the coefficients here and you could put them in this formula. And if you manipulate them just as the formula tells us to manipulate them, you can find the two solutions of x. Notice we have plus or minus, and that's where the two solutions are. That's where they exist, in the plus direction and in the minus direction. But the idea here is that from the coefficients comes the answer if you manipulate those coefficients just so. And you might wonder, well, if you had a cubic equation in standard form, could you take those coefficients and put them in some formula and come up with the answers? And this becomes a very deep question that's been answered in math. But essentially, yes, there is a cubic formula. There's a quadratic formula. There's a cubic formula. There's a quartic formula for x to the fourth, but there is no quintic formula. Finding that out was a lot of important historical math. Well, here is the quadratic formula, and this part of the quadratic formula is what they call the discriminant. And from this, you can draw some conclusions about what kind of solutions you're going to get, and that's what this problem is all about. They want us to evaluate this and select one of these possibilities. Now, let me just point out one possibility here. Suppose that b squared minus 4ac goes to 0. That is, this simply vanishes. Notice what we have here is plus or minus 0. And so what we're going to have here is negative b over 2a. We're going to have one solution. In other words, we're going to have a double root. It's going to be one solution, and if we were to draw this, the vertex of the parabola would be right on the x-axis. So that's one case. Then there are other cases that you could possibly have. For instance, what happens if this evaluates to a negative number? Well, then you're going to have the square root of a negative number, and you're going to have imaginary numbers, right? And so you'll have two imaginary, a plus imaginary and a minus imaginary solutions. And so that's the game here. Here is the quadratic equation they've given us. I've written the coefficients in black, like so. Our a is equal to 1, our b is equal to 1, and our c is equal to 7. The discriminant is going to be b squared minus 4ac. And so b is equal to 1 squared minus 4 times a times c. A is equal to 1, and c is equal to 7. So we evaluate the discriminant, and we get 1 minus 4 times 7, or 1 minus 28, or negative 27. And so the discriminant is negative. That means this part right here is negative. And so we're going to have plus minus square root of a negative number. We're going to have two imaginary solutions. And I look here at the possibilities. Do I see two imaginary solutions? And I do right here. So that's what's going on here. Let's do a submit. Well, I hope that helps. I know I was chattering away here. Thanks for listening, and I'll see you in the next bonus quiz.